All right, everyone, welcome to our July Midday Science Cafe. We're so excited to have you here for It's Elemental, Lithium Recovery for a Sustainable Electrified Future with Dr. Michael Whittaker from UC Berkeley and Berkeley Lab, and Meg Slattery from Berkeley Lab and now UC Davis. Just a few things before we get started. You can find closed captioning for the Midday Science Cafe in Zoom. Either it popped up automatically or it's in the 3 dots under More. But feel free to open those up and follow us in text as well. This is being recorded and we'll post this video to the Science at Cal YouTube channel and the Berkeley Lab YouTube channel, and we'll share that link with you all via email once it's posted. You may not recognize me. I'm a new face. I'm Michelle Rodriguez, and I'm so happy to be with you all today. I'm Science at Cal's interim public engagement specialist, while Dee is out on maternity leave. She just had twins, so congratulations, Dee, and we can't wait to have you back. As we normally do with our Midday Science Cafes and all of our programming, we're going to start today with a land acknowledgement. We recognize that Berkeley sits on the Hu-Chun territory, the ancestral and unceded land of the Ohlone people, the successors of the historic and sovereign Verona Band of Alameda County. This land was and continues to be of great importance to the Ohlone tribe and other familial descendants of the Verona Band. Every member of the Berkeley community has and continues to benefit from the use and occupation of this land since the institution's founding in 1868. And by offering this land acknowledgement, the Berkeley community not only recognizes the history of the land on which we stand, but also recognizes that the Ohlone people are alive and flourishing members of the Berkeley and broader Bay Area communities today. And thank you for allowing us this time to give us this land acknowledgement. Science at Cal since 2008 was envisioned as a unifying effort to raise public awareness, understanding, and appreciation of science research at Berkeley. And to realize this vision, we engaged the vast Berkeley science, technology, engineering, and mathematics community to foster creative collaborations among campus and community-based groups who share our commitment to equity and inclusion in STEM education and careers. Science at Cal connects researchers with diverse community groups of all ages and backgrounds for scientific engagement and learning. Accessibility, inclusiveness, creativity, and innovation are all hallmarks of Science at Cal events, which reach tens of thousands of people annually. And throughout the year, Science at Cal presents ongoing free outreach programs on and off campus, helps promote related efforts, and creates new programs and initiatives at Berkeley and in the community. This broad scope of activities is made possible by Science at Cal's dynamic network of campus alliances and valuable community partnerships. And before I hand things over to Berkeley Lab, before I even do that, I wanted to share with you that our next Midday Science Cafe is going to be August 17th from 12 to 1:30, as it usually is, and our focus is going to be on earthquakes, so that's very exciting. Before I hand things over to Berkeley Lab to say hello, I also want to share with you that these events are always really interactive and we expect a ton of Q&A. So please add your questions into the chat or the Q&A box. You don't need to put them in both. And then we'll get to as many questions as we can. So I'm going to hand things over to Jen Tang, to share with you a little bit more about Berkeley Lab.
Awesome. Thanks so much, Michelle. I'm so glad that you're joining us this month. So as Michelle mentioned, I'm Jen Tang, and I am the Director of Community Relations at Lawrence Berkeley National Laboratory. And for those who aren't familiar, Berkeley Lab is one of 17 U.S. Department of Energy national laboratories across the country. We're supported by the DOE's Office of Science, and we're managed by the University of California. All of the research we conduct at the lab is unclassified. And since our founding in 1931 by a Berkeley physics professor named Ernest Orlando Lawrence, we've been dedicated to advancing the scope of human knowledge and seeking answers to some of the greatest problems facing humankind. Now, today, Berkeley Lab employees work together to develop meaningful scientific solutions to the world's most intractable energy and environmental challenges. We also help train the next generation of scientists and engineers, and we ensure that those things happen in a manner that benefits everyone. Our main campus is located in the Berkeley Hills, and our close ties to the UC system create a really unique and synergistic environment for scientific discovery. A number of the lab's researchers are affiliated with one of the UC campuses as either students, postdocs, or professors who may have a joint appointment to do research at the lab. And we're really fortunate to have an especially close relationship with UC Berkeley. Our institutions have joined forces to advance science across many frontiers. And one of the main motivations for our Midday Science Cafe series is to share with you examples of those compelling and complementary scientific research initiatives from both of our institutions. So we hope you enjoy today's presentation. And with that, I'm going to hand things back over to Michelle, who will introduce our first speaker.
Hi, everyone. Thanks again for having me here. And I'm excited and honored to introduce our first speaker, Mike Whittaker, to the screen. Mike is a research scientist in the Energy Geoscience Division in the Earth and Environmental Sciences area at Berkeley Lab, and an affiliate in the Department of Earth and Planetary Science at UC Berkeley. He received his BS and MS degrees from the University of Utah in Materials Science and Engineering in 2012, and his PhD from Northwestern University in Materials Science and Engineering in 2017 with advisor Dirk Joster. Mike worked as a postdoc in the nanoscience group, I love the love, in the Energy Geoscience Division from 2017 to 2020 with Benjamin Gilbert and with Jill Banfield at UC Berkeley. He's the co-founder and director of LYRIC, the Lithium Resource Research and Innovation Center at at Berkeley Lab. Mike, it is our pleasure to have you speak with us today.
Yeah, thank you so much, Michelle. Great, thank you. Let me get some slides up. It's an honor to be with you today. Thanks so much for the invitation to talk about lithium and many things beyond. As you mentioned, I've been working as the director of the Lithium Resource Research and Innovation Center, which is connecting researchers across Berkeley Lab, ranging from geoscientists trying to understand how lithium ends up in the ground in the various forms that it takes, to the chemists who are trying to understand how to potentially convert that into useful chemicals that supply the material scientists who are designing battery materials, specifically lithium-ion battery materials, and a number of analysts and technologists who are then thinking about how to recycle those batteries and how to incorporate them into global supply chains. So it's a really interesting and timely topic, and happy to be giving just a little bit of overview from our perspective. The basic underlying premise of the work that we're doing on lithium is that there's a broader picture that's coming into focus as we think about transition to renewable energy generation and storage, which is that minerals are the foundation of clean energy. And this World Bank report, called Minerals for Climate Action, summarizes this case nicely. Here on this graph, we have three different scenarios, climate scenarios. RTS is basically the do nothing scenario. This is what's going to happen if we don't mitigate climate emissions. 2DS is staying at 2 degrees of warming, and B2DS is staying below 2 degrees of warming. And what you see plotted here on the y-axis is the total mineral mass that the world is going to need to mine in order to meet these various scenarios. So the more ambitious we would like to be on climate change, the more minerals we're going to need to mine. And so this report from the World Bank sums it up by saying greater ambition on climate change goals will therefore lead to a greater mineral footprint. And this really is the fundamental paradox of the clean energy transition, because I'm sure as you heard me explain this, you thought to yourself, well, mining is not very clean. If we need to do more mining to meet climate goals, how does that square? How are we going to make that really a sustainable future? And so that is precisely what LYRIC and the researchers at Berkeley Lab are hoping to address. So when we talk about minerals, of course, we think about lithium, but we also think about critical minerals and materials more broadly. So this is any chemical element that we need to create sustainable and clean energy infrastructure, things like photovoltaics, silicon for solar panels, things like batteries, lithium, but also cobalt and nickel and many other things. And then things like aluminum and iron that are needed to make things like wind turbines and electric vehicle, vehicle chassis and other parts. And so when you break it down like this, what you find is that critical minerals or really critical elements is what we're talking about, comprise over half of the elements on the periodic table. So anything in blue here is something that the United States federal government has considered within the past couple of years to be critical. Everything in red is something that's either unstable or is exceedingly rare on Earth. And so you see far more blue and red here than you see whites, which are the things that we actually have at our disposal. And what's becoming increasingly true after over a century of industrialization is that concentrated ore bodies, think a solid gold nugget, for example, are either largely depleted, have already been exhausted, or for certain elements never formed in the first place. So the new paradigm we have to grapple with here is that we need to use dilute sources of critical minerals that might contain many of these critical elements, but in relatively low concentrations. And that only makes the mining challenge harder because it's not really what our mining technologies have been designed for. And the fundamental issue here basically comes down to entropy and information. So entropy, this quantity S, we typically think about as being proportional to the logarithm of W, where W is the number of ways that something can be arranged. W, in other words, is essentially a measure of how complex something is. And so for mineral resources, these dilute sources we think of as being very high entropy. There's a large number of ways that these elements can be arranged, and they're very complex. And that's contrasting to something like a gold nugget, where all of the gold atoms can really only be arranged one way, and we consider that to be very low entropy. So our new resource paradigm is this high entropy paradigm. And so there's an interesting analogy to information, where the information defined by Claude Shannon is also proportional to a logarithm, this time the logarithm of P, where P is something like a probability. And another way to think about this is how surprising something is. Okay, so again, think back to mining for gold, for example. You don't know where the gold is. You have to go out and look for it. And when you find it, you're very surprised. And so when you find a big gold nugget, you get a lot of information about where the gold is and how much it weighs and all that. But our information about our complex resources is very low. And really, this is a result of this complexity, right? So you see the sort of parallel here. And so to plot this is the logarithm function here. And our resources, our natural resources, like those containing lithium, sit up here, where you might need a little knowledge about a lot of things. You need to know about the lithium and the silicon and the aluminum and all of the other sort of mineral constituents that you might find in the rocks in the subsurface. But ultimately, you need to get to a place down here where you're forming a product like a battery, where you need very detailed knowledge of just a few different things. You need that battery to be designed very specifically to certain engineering tolerances, and you need those batteries to perform the same way every time, and they need to have the same life for every customer that you sell them to. And so our challenge really is traversing this entropy curve or this information curve, so that we know both a little bit about a lot of things in the resource and have a detailed knowledge of a few things in the final products that we're making. And so the take-home message here is that more dilute resources require a lot more information. And that's especially true even of things you don't necessarily care about. So you need to know about lithium, but you need to know about everything else around the lithium because it's an important part of the complexity of that resource. And so that's where Lyric comes in briefly. I'll just give a little pitch for LYRIC, the Lithium Resource Research and Innovation Center. That's basically, the premise is we can't build the new energy system with the tools of the old energy system. This is something that one of our LYRIC partners, Alex Grant, said that very much rings true. We have to really rethink how we're getting from a resource to a final product. So Berkeley Lab does a lot of diverse research, as Jen mentioned in her introduction. We do a lot of geoscience. We have a water innovation hub, water being important to something I'll talk about on the next slide. And we do a lot of battery research and technology. So this is a great place to link what happens in the ground to the products that we make from those raw materials and draw sort of a straight connection between them. We have hands-on training. So this is where we get experience doing the actual generation of information, right, that we need to better understand these resources at places like the Molecular Foundry, the Advanced Light Source, which is our X-ray source, and our NERSC supercomputer. We do, obviously, time is of the essence here, and we are very interested in getting the solutions that we develop to the lab out into the world quickly. So we do that through various entrepreneurship activities like Cyclotron Road, and we also have engaged with a number of important industrial partners who are at the forefront of many aspects of things like lithium supply chains. And we also think it's very important to engage in community partnerships while we do this. This is Meg's wheelhouse, so I'm going to leave that to her in the next segment of this talk. But first, let's talk about two sort of case studies in topics that LYRIC is addressing to try to change our mineral use paradigm and prepare ourselves for the sustainable future. And the first one is geothermal powered direct lithium brine extraction. So many of you may be familiar with geothermal brine and geothermal energy. It's when you take a hot brine, which is very salty water, you bring it up from the Earth's subsurface and you use that heat and water to make steam, which turns a turbine and generates electricity. In typical geothermal power, that water that's cooled down is then just sent back into the Earth's subsurface where the rocks warm it up again, and you can do this in somewhat of a closed loop. The proposed technology innovation here is that we now know that there's some amount of lithium in these brines. And if we're going to need a lot of lithium and we're bringing a lot of brine to the surface, hey, why aren't we extracting it? And so that's what's being proposed here, where there's an extra step that's tacked on here to extract lithium from the brine while it's up at the surface. And then that lithium depleted brine can be sent back down. There are a number of different technologies that are proposed for this. All of them share sort of the same general paradigm, which is you have this complex brine up here in the top left-hand corner. And from this complex brine, you want to extract the lithium and leave everything else in the brine so that it can be sent back down underground. And this is precisely the technology challenge that LYRIC scientists are addressing for this, what's called direct lithium extraction. Another approach that we're taking is in a project that we call MINES, or Minerals for Energy Storage, where we've introduced a new paradigm called separations by synthesis. This is the idea that instead of digging a big open pit mine in the ground, bringing minerals up to the surface, extracting only what we need, which is typically on average in mining less than 1% of everything that you're actually mining, and making a product from that. We want to do this in a much more holistic way and really reduce both the carbon usage and water usage of these really sort of otherwise resource intense processes. So we wish to reduce waste of both energy and waste of material or matter. And here we're proposing to directly synthesize some battery components, and in this case, the cathodes or solid state electrolytes, directly from the minerals themselves. So just very briefly, the conventional approach to processing rocks that contain lithium is to mine them, where this logo here indicates that this requires a lot of diesel or hydrocarbon fuels. You crush them, you mill them, Then you have to float the particles in water to separate out the lithium from the particles that don't contain lithium. You filter, and then you go on through this long sequence of really energy intensive steps until you end up at the synthesis portion of the chain, where you mix everything together, make a battery material, and then put that into your battery cell. The new paradigm is going to leverage the science that we're doing at Berkeley Lab to do this in one step, and to do it much more efficiently, powered by electrification, where we're making the material that we want and some kind of mineral byproduct that can be either left in the ground or put directly back. So basically, to summarize, both of these examples, both the geothermal direct lithium extraction and minerals for energy storage, use new methods for subsurface separation and conversion. And it all starts with a better understanding of what's happening under our feet. We need more information about these complex systems in order to make this work. If we can do that, though, it's been proposed that you can do a lot of this in situ or underground. So instead of digging a big hole in the ground, you can do a lot of mineral processing in the subsurface, where there's less opportunities for pollution to enter the air or enter the water. So the idea is basically that you could put things like wind turbines or solar panels on the surface above some sort of mineral resource, and then drill down into the mineral resource and use things like electrochemistry to liberate elements that you want and separate them out underground and bring only those up to the surface. And so this looks very similar to the geothermal case, but instead of having a resource which is already a brine that's easy to sort of pump and flow, you also use the electrification to help move the elements that you want. A lot of this is under active research and development, and while we do that, again, it's important for us to get these technology solutions that work out into the real world. And so in parallel with a lot of this work, we do things like life cycle assessment, which is assessing the total impact of these processes. That includes things like water quality, air quality, energy usage, and really sort of an end-to-end accounting for how potentially beneficial a process could be. And also techno-economic analysis, understanding that if one of these processes requires a huge amount of platinum or something expensive, then it's obviously never going to be feasible in the real world. And so we take that into consideration as we're going. So to summarize, 3 main points. One is that mineral sustainability is the fundamental paradox of the clean energy transition. We have to do better at mining to get all of the raw materials we need for clean energy infrastructure. To do that, we need more information about the mineral resources in order to use them sustainably. Because they're so high entropy, so complex, we need a much larger amount of information about them in order to do things efficiently. And finally, the future of mining may lie mostly, if not completely, in the Earth's subsurface. And there are a lot of new, exciting possibilities for this, including one that Meg is going to talk more about, which is this geothermal direct lithium extraction. So with that, I'll conclude, and I will be happy to take any questions.
Awesome. Thank you so much, Mike. That was really fascinating. You've got some questions already in the chat. And so let me ask you just a few of them. I'm going to ask you one of them. There's some theme around efficiency of this mining process. So how efficient is the lithium brine process? How much energy is required for extracting enough lithium for one EV battery? Is geothermal use big enough? So maybe that as one chunked question right there.
Yeah, let's see. Can you
yeah, let me ask it again. Yeah, so how efficient is this lithium brine process of mining? How much energy is required to extract enough to make a battery? So is there a connection that you know of that can tell you if it is like how much energy we're using in order to extract this lithium from the geothermal areas in the Salton Sea area?
Yeah, so the beautiful thing about the geothermal lithium extraction is that the power essentially comes for free, in that the geothermal power is already being generated. And in this particular case, in the Salton Sea in Southern California, these geothermal plants have been around for 30 years or more. So the energy is there. Now, the energy that you need to use to extract the lithium sort of reduces the total amount that can go out into the grid. But basically, the answer to that question is that the lithium extraction step right now, as it currently stands, is much smaller than the total amount of geothermal power that's being generated. So we don't have an apples to apples comparison of what the power consumption of lithium extraction is when it's done at the same scale. But right now, the energy usage for lithium extraction is not very high. The bigger concern is material and water usage. So the power consumption is a problem that they think they have solved, but it's not the only one.
Awesome, thank you. And then I got Meg also can speak a little bit more to this recycling question. So Meg, we're going to look forward to that. Let's see, I'm going to ask one more question before we move on. I guess this is sort of a two-part question. And so you had just mentioned about fresh water or water. If you wouldn't mind saying a little bit more about the projected use and source of fresh water required to extract lithium from geothermal wells in Lithium Valley, including the quantity of fresh water needed to wash the lithium from the resin particles, and what residues are contained in that spent fresh water. So I think I'll just leave that question at that.
Mm-hmm. Yeah, it's a great question because, of course, talking about water issues in the Western United States is at the forefront of a lot of people's minds. Mm-hmm. It's the short answer is it depends. There are at least 3 different technologies that are being used currently, sort of at the demonstration scale in the Salton Sea. One of them doesn't require much water, but requires a lot of chemicals like acid. One of them does require a lot of water, and that could really be a potential issue. So basically, it still depends, and because the technologies that different companies are using really differ quite a bit in sort of the inputs that are required, it's really still to be determined what the ultimate water impact is going to be, because it depends on obviously ultimately the economic success of the various companies who are implementing those technologies. In terms of the effluent or the impurity content of the brines after the lithium separation step, and lithium having been stripped from a sorbent, what is the chemical makeup of that, and can that be released, or how does it need to be treated? Typically, it's envisioned that that's going to be sent back underground, and that will not commingle with any of the fresh water supply at the surface. Again, that's technology dependent, and we only have partial details about some of the proprietary technologies that are being proposed. So that's still definitely an area of active investigation. And we have, I guess, as a final note, I'll just make a pitch for this. We have a team who has been working diligently on answering questions just like that for a project funded by the Geothermal Technologies Office at the Department of Energy. They're preparing a report now, and Meg, who's speaking next, has contributed to that report. And it should be released sometime within the next month or so, and they'll have much more quantitative numbers to answer these types of questions. So be on the lookout for that.
Awesome. Thank you so much. I know there's a lot of thought about how to do this well. So I appreciate that things are going on, and we're going to learn a little bit more about what else is happening. So I'd like to turn things over to Jen to introduce our next speaker.
Awesome. Thank you so much. And Mike, that was a fantastic presentation. So it's now my pleasure to invite our next speaker to the screen, Meg Slattery. Meg is a PhD candidate at UC Davis, where her research explores the intersection of industrial ecology and social justice, incorporating stakeholder perspectives to inform a holistic understanding of the lithium-ion battery supply chain. Meg has conducted extensive interviews to map out the EV battery reuse and recycling network, and she's co-authored a report that provided policy recommendations to support reuse and recycling in California. She's incredibly passionate about bridging the gap between academic research and frontline communities near mineral extraction sites, and that's led her to collaborate with a Berkeley lab team that's studying lithium resources near the Salton Sea. Her goal is to understand community perspectives and make the research more relevant and accessible. Her work has been published in peer-reviewed journals, and she's contributed to reports for the International Energy Agency, the United Nations Environment Program, and the Climate and Community Project. And prior to pursuing her academic career, Meg gained valuable experience through 8 years of work in the restaurant industry and 2 years working for Grupo Phoenix, which is a small nonprofit in rural Nicaragua. She holds a Bachelor of Arts in Science, Technology, and Society from Vassar College, and she has a Master's of Science and Energy Systems from UC Davis. And with that, Meg, I'm going to turn things over to you.
Great. Thank you so much, Jen, for that introduction. And thank you, everyone, for joining us today. I really appreciate the invitation to speak and your interest in the work we're doing here. Are my slides looking okay?
They look great.
Okay. Great. So like Jen said, I'm a PhD candidate in the energy graduate group at UC Davis. My research is about different aspects of the battery supply chain, but today I'm going to talk specifically about how I've tried to incorporate more community engagement into research about lithium. To give more background on the research that we do, so at UC Davis, I've worked a lot with Alyssa Kendall, who's my advisor, and also with Jessica Dunn, who has since graduated. But we've studied the circular economy for lithium-ion batteries. A lot of that has been understanding what happens actually to an EV battery today when it's taken out of a vehicle and what network exists for managing that and doing collection and transportation. And sort of based on that, what are the implications for reuse and recycling policy? We also do industrial ecology research. So that's material flow analysis. A lot of that was led by Jess. Estimating the amount of different materials that would be demanded under different sales scenarios for electric vehicles. And we've also done some work looking at, I think this relates to an earlier question, looking at how much material would be demanded and could be met with recycling under different transportation scenarios. And that was led by Christy Diamo. I'm also currently working on a life cycle assessment of direct lithium extraction that's guided by some of the community priorities I'll talk about today. And then the bulk of my presentation today will be talking about the work I've done as an affiliate with Berkeley Lab. So this started with an internship with Lyric, I believe in 2021. I worked with Mike on identifying what would be community-driven research ideas. And then for the past year or so, I've been working on incorporating community engagement into the Department of Energy study that Mike referenced earlier. Before I want to start, I want to introduce some key concepts in environmental justice that have been really helpful for me in my understanding of the battery supply chain and where I see the role of research in supporting this. So I think a lot of us, when we think of environmental justice, think of distributive justice. So that looks at how the burdens and benefits of a development or technology are distributed. In the case of electric vehicles, we could look at who is experiencing environmental burdens from mining, for example, and who's experiencing benefits either in the form of revenue or in terms of cleaner air quality. But there are these two other aspects of environmental justice that are also really important to keep in mind. One is recognition justice. And so that you would look at who lives near this area where you're talking about a proposed development, how do they relate to the environment, and what ways of engaging and participation would work for that particular group. And then procedural justice, which is also very related, looks at who is able to meaningfully participate in decision-making processes. And in reality, all of these are really interact and enforce each other. So if you have a situation with unequal distribution of resources, there may be some communities that have a more difficult time participating in decision-making processes. And then that in turn is likely to lead to a less just outcome or a less distributively just outcome because they might have a harder time advocating for what they need or just bringing up certain issues. There's a lot of systems that go into whether this cycle kind of results in more environmentally just outcomes. And research is just one part of that. But I think where I focus is the importance of research and procedural justice. And so for communities to participate in decision-making processes, they need information about what's going on. And it's really important that that information be provided accessibly and that it be relevant and address their concerns before the development takes place. And that's really what we've been trying to work towards here. I also want to give a bit more background on Lithium Valley before I dive right in. I know it was alluded to in Mike's or not alluded to, it was spoken about in Mike's presentation. But to give you more of an understanding in case you're not familiar with the area, the lithium resources are near the Salton Sea, which is on the very southern end of California, pretty close to the border of Mexico in Imperial Valley. And then it's Eastern Coachella Valley up there at the top. At the moment, there are 11 operational geothermal facilities in the area, and 3 companies working on extracting lithium from the brine. And to give you a sense of how much lithium is there, this is just how much is flowing through, not necessarily the amount that could actually be produced, but it's roughly the amount of lithium that could be in 2,070,000 kilowatt-hour Tesla batteries, or nearly 150 million sizable e-bikes. Lithium Valley, that term kind of first started being used widely in around 2019. The local assembly member, Eduardo Garcia, convened the Lithium Valley Commission to discuss and kind of make recommendations about building a sustainable lithium industry in the region, as well as potentially a battery supply hub. So having more of the value-added processes with cathode and component manufacturing as well. This ended up being really helpful for me in my research because the Lithium Valley Commission met every month. The meetings were publicly accessible and transcribed, and they provided a lot of opportunities for me to understand what people's priorities were there when they were already kind of showing up to voice their opinion. There's also, I want to just flag that there are a lot of ongoing environmental justice initiatives to support a more inclusive development in Lithium Valley. So because of existing environmental justice challenges in the region, there's an active network of grassroots community advocacy organizations. So 2 that I've listed here are Comité Cívico del Valle and Los Amigos de la Comunidad. And both of them are involved in outreach and participated, or the director of Comité Cívico participated on the Lithium Valley Commission. And they're both heavily involved in gathering community input on how to invest tax revenue. The potential tax revenue is also related to state efforts to develop this industry in a way that will benefit the local community. First with establishing the Lithium Valley Commission, but then through the passing a lithium extraction tax law. And that specifies that their revenue be invested, a portion of the revenue be invested in frontline communities. And then finally, for workforce development, Imperial Valley College is currently creating programs. So they're starting with a plant operator program to train students for lithium related careers and ensure that more people are qualified for the jobs that will be created. And I want to flag just to say that this is not the work that our research team is doing. The research team, as I'll talk about in a second, is really looking more at this technical aspect, but it's information that's really relevant to this development. And so the question is kind of how can we plug in and be helpful and support these ongoing efforts? I'm going to drink water here. So just to give a little bit more information also about this pilot study, the research objectives, I think the information from this project, I think will respond to a lot of the questions that I saw in the chat. But the research team was looking at the lithium and geothermal resources in the Salton Sea known geothermal resource area. So looking at how do we expect the reservoir to behave over time? How do we expect the concentration of lithium to develop, and how much lithium do we think is there? And then also evaluating the environmental impacts, including water use, air emissions, and solid waste associated with expanding geothermal power production and extracting the lithium. Community engagement was added, and that was when I was brought on to make sure that that information is available not only to the Department of Energy and people who can access the technical reports, but also to local stakeholders, because obviously this information is highly relevant to them. So we were looking at how can we make sure that we're generating information that's relevant to them and communicating it accessibly and getting feedback and learning from people. With my lyric internship, was unstable. Is my audio okay?
You were cutting out a little bit there, but I think we've got you back.
Okay. Okay. Let me know if it's an issue. But so the first step to understand what community priorities were was accountability, who are based in the Eastern Coachella Valley. And through
Meg,
that
I think
connection,
we're getting a little choppy. Do you maybe want to try turning your video camera off to see if that helps? Thank you.
Yeah, is this better?
Sounding good so far.
Okay, sounds good. So like I said, we connected with Leadership Council for Justice and Accountability. And through that connection, we're able to attend community meetings and just recorded all of the questions people asked that were related to lithium. And then we also conducted a review of peer-reviewed and industry-reported literature about lithium research to understand what information existed to respond to their questions and where there were research gaps. So this figure to the right is looking at, it kind of quantifies how much the two groups talked about certain impacts. And so you can see in local community meetings, the water consumption, employment, and public health were really the issues that were top of mind. Compared to in the Lithium Valley Commission, shared a strong emphasis on water and employment, but had relatively less focus on public health. And so a lot of peer-reviewed literature mainly focuses on the greenhouse gas emissions, and there's kind of a knowledge gap about these local impacts. And so some of our research recommendations were to evaluate water consumption in the context of regional availability, include local air emissions and waste streams and sustainability analyses, and then monitor impacts over time to make sure that the promises that are made during the planning process are realized during development. And then a big thing is also just communicating information more accessibly, because this information might exist, but it might be in an environmental impact report that's 1,000 pages long, or it might be in a technical report that's very difficult to understand if you don't have a technical. So putting that into practice, to one of the ways that we're trying to make the information from the Department of Energy study more accessible is by putting it in the format of a frequently asked questions document. So these questions were synthesized from the content analysis that I mentioned before, and we also pulled all the questions from the Lithium Valley Commission public comment docket and got input from local organizations. So there are several topics here that you can see will be addressed in the FAQ document. And then we're also making a point to highlight questions that are out of scope for this research team, because there certainly are other questions that are top of mind and really important to environmental justice in this development about workforce, how revenue will be invested, what opportunities people have to participate, and the impact on public health. So where we don't have the data, or it's not really appropriate for us to be the ones responding to those questions, we're making an effort to explain why we can't and point to the people who those questions can be directed towards. At the moment, I'm kind of translating the information from the technical reports into this format. Then we'll get feedback from the research team and local organizations. It will then be translated into Spanish, and then we will distribute this and hold briefing workshops. We also held, the research team did an outreach visit in May. So that included a community workshop in Niland, California, which is the closest town to the geothermal power plants. And we also visited Imperial Valley College. Some of the efforts that we made to make sure these were accessible were we tried to schedule the events at convenient times. So we had the workshop on a Monday evening from 6 to 8 p.m. And then we visited both day and night classes at IVC. and provided food to just make it easier for people who were busy and living busy lives to be able to participate. We had printed materials provided in English and Spanish. I can talk more about the decision-making around interpretation, which we learned a lot about. And then we also structured the events to have more time for questions and feedback, and make sure that we were avoiding just giving people a ton of information and not having time to hear from them about what they thought and what they wanted to know, and feedback for us. Some of the feedback that we did get were that we should be hosting more workshops in other communities and online to make sure that the information is available to everyone, and that we needed to better coordinate with local partners. So for example, coordinating more with Imperial County or with the companies would have also enabled us to respond to more questions, not just the ones about environmental impact and the resource. And really importantly, I think it's important to hold these types of events in formal partnerships with local organizations moving forward. So in this case, we kind of got input about how to go about it. But again, I think having formally co-hosting would be a better approach for the future. And that was made clear to us. Over to the right are some results from a survey that we distributed to be able to get feedback about the workshop and understand people's perspectives. And what I want to highlight here is that most of the people who responded in this particular case both agree, at least both agree that they think lithium extraction and geothermal would have a positive impact on the community, and they're also concerned about the environmental impact. And so I think it shows, people, it's really not black and white where people either think that it's going to be a bad thing or they only care about jobs. I think in general, everybody just wants to have more information and they want to be involved as this moves forward. I want to also flag that community engagement in research is actually a pretty robust field. It's been most widely developed in the field of public health and has existed for decades. And so this paper, The Continuum of Community Engagement in Research, I highly recommend reading. It was really helpful for me. But they put community engagement in research on a spectrum. So on the left, you have no community involvement, which is somewhat typical for more quantitative traditional science fields. And then on the right, you have community driven, where the community is really in charge of what's getting studied, how it's getting studied, and how it's communicated. I would say this study falls kind of in community consultation, where we got input about the research before we started. We tried to connect it to the community priorities, and then we're getting input about how to communicate, but it could be made more participatory and more engaged. And some of the ways people have done that in other areas are establishing a community advisory board, including participating community members when sharing or discussing research findings. So that could be inviting them to speak on panels and including them in authorship of papers, making sure that you're recruiting local research team members and having more formal partnership with community-based organizations. Some of the challenges for this particular topic were that it's a complex novel technology. So a lot of the information doesn't really exist yet in a really concrete way, which makes it difficult to give a straightforward response to people's questions. And I think that just points to the importance of ongoing monitoring and communication moving forward. And then another challenge is that establishing trust and building relationships and doing community engagement in a meaningful way takes a lot of time. And meanwhile, climate change mitigation is very urgent, and there's a huge push to develop these resources very quickly. So that is just a challenge. Community engagement requires some skill sets that are less typical in quantitative fields. So it requires more thought into graphic design, event planning, social science, IRB approval. And that's, I think, something that research teams should be aware of if they're looking to incorporate this. And then also, I think it's really the most effective if it's incorporated into the overall project management from the beginning. So that could include establishing a formal partnership with a local organization, and then also defining how members of the research team are going to be part of the community engagement effort. And finally, you need to be aware that you'll have to budget more time and money to communicate with specific audiences and translate documents. In conclusion, I think this is, while it's challenging and takes more time, I think it can really enrich our research. And I think it's really important to be bridging this gap as we're developing these new energy and transportation systems, so that we can be part of empowering communities to participate and supporting climate solutions that are more sustainable and equitable throughout their entire life cycle. Thank you to everyone listed on this page. And this is my contact information, and I'm really happy to take questions.
Fantastic. Thanks so much, Meg. That was a great presentation. We do have a couple questions we wanted to ask you before we bring Michelle and Mike back for the fuller conversation. So somebody wanted to know if it was fully developed, what portion of global lithium demand, let's say through maybe like 2050, would Lithium Valley be able to provide?
So I think I was just looking this up. That answer does depend on how mobility solutions play out. I think the less material intensive our transportation system is, the greater a portion of that demand could be supplied by Lithium Valley or by other kind of more sustainable sources of lithium. But I think the IEA was projecting like 10 million electric vehicle sales for this year. And so if you look at that, and if the lithium throughput now is probably around 2 million, then that kind of gives you a sense. But we hope to be able to provide a more solid answer to that as we work through this FAQ document.
Got it. Thanks, Meg. And somebody in our audience noticed that, Nyland is in the area. I know you talked a little bit about some of the feedback you got from that community. Are there any, so the question was, how has that community responded to the proposed, lithium extraction plans? You talked about it a little bit. Are there any other details that you might want to be sharing with our audience?
I think I can share my perspective and what I've heard. I don't want to speak for anyone there. But in general, I think there's sort of, this equal emphasis, which you kind of see in the survey results, of wanting to make sure it's sustainable and not going to further damage the environment in their area, but also seeing the promise of having job creation and more meaningful career pathways for people who live in the area. So I think people, and also like different people will have different perspectives on it. But I think I hear both of those, both kind of a recognition of the promise and the opportunity that's there, and then kind of also a skepticism about whether it will develop in a way that benefits them, and kind of how people will be able to access those jobs and what the environmental impacts will be.
Got it. Thanks, Meg. I really appreciate that thoughtful answer. Well, let me do this now. I'd love to invite both Michelle and Mike to join us on the virtual stage, and we can delve into some of the questions that we've gotten from our attendees. And thanks so much, by the way. Those are great questions. Keep them coming. Okay, so Michelle, why don't I hand things over to you, and you can ask the first couple questions.
Great, thank you so much. We have sort of thinking about Meg, what you were just talking about other solutions, and trying to see that there are benefits and there are also like complications and concerns. There were some questions earlier on in the presentation about both presentations about sort of other ways to handle this. So do any powers that be discuss slowing down global production that's happening all the time, and consumption, and instead moving toward like looking at maintenance instead of this growth? So for both of you, do you guys know of one, like who are those who's making decisions about that? But also what kinds of decisions and conversations are happening right now around, rather than ramping up, are there ways to maintain and like slow down?
Meg, do you want to go first, or I can
Go ahead,
respond? Meg. Okay, so I don't necessarily know that the powers that be per se are having those conversations, but I think that's certainly starting to be more part of the conversation of what kind of policies would reduce mineral demand while also enabling decarbonization. So my advisor, Alyssa Kendall, and another grad student, Christy Diamo, and I were part of this report with the Climate and Community Project that I can try to find the link to. And so we looked at what the lithium demand would be under different scenarios, like if there were more dense, if cities were designed more densely to enable easier public transportation or more biking and walking. And then also just having smaller cars are also as well as like right to repair and making those batteries last longer. So those are all ways that we could have a system that overall reduces mineral demand. But that said, I do want to flag that even under those cases, we still would need from some amount of lithium, even for e-bikes or micromobility or electric buses. It doesn't get us really out of needing some amount of lithium demand in the future, even in a wildly optimistic scenario. And then another related question was about battery recycling. And I do think that will play a huge role, and that actually is developing in a way that's really exciting. But the amount of batteries, because the demand is growing so quickly now, and there aren't that many electric vehicles today, there won't be that many retiring in 10 years. So it's going to take research looking at that says it's probably going to be at least until 2030, recycling is not going to be able to meet a significant portion of demand.
Yeah, I was going to echo that same point, Meg, and also just say that if we stop, developing renewable energy technologies, then we arrest, renewables penetration at current levels, and that would be catastrophic, according to the IPCC, right? We have all of their scenarios that I showed in my first slide about projecting to remaining below a certain threshold level of warming are predicated on continued growth and penetration of renewable energy technology. So if we stop that, we will be even worse than sort of the do nothing scenario, which is sort of continue on the current course of action. And so really that's why this paradox exists. We don't have a choice. We need to get to a renewable energy economy. And so we need to make these changes. We have to do more technology development to make that possible.
Great, thank you. Thank you both for that really thoughtful response, and thinking about how we're trying to handle this moving forward in the world that we live in right now. Sort of related is a question then, or maybe a follow-up to that. Could these then, the sustainable methods of lithium extraction that you guys are talking about, then be used to make the existing lithium mine and brine extraction less environmentally destructive? Is that the goal? Like, is that your end goal and goal of this?
Yeah. I mean, part of the vision I painted of sort of doing a lot of the resource extraction that we need underground is a long-term vision. Mm-hmm. Mining is a very big industry that tends to move very slowly. And so in the interim, we're working to develop solutions that can actually be implemented today with, existing mining operators to at least improve the efficiency of some of the processes that are already happening and are going to happen as we transition to an even less impactful scenario, 15, 20, 30 years down the road.
Yeah, and I realized I'll be quick, but I kind of skip over this sometimes when I'm talking about Lithium Valley. Part of the main draw for it is that direct lithium extraction is expected to have a much lower footprint compared to how lithium is produced today in terms of the energy, land, and water that's required. But most of the time, that's all people talk about when they talk about it. And so that's what leads to this kind of absence of information about, okay, well, even if it's much better, it still will have some type of impact. So how can we also study that? But it is expected to be significantly more sustainable.
That's really great to hear. I'd love to turn it over to Jen for a couple more questions.
Awesome. Thanks, Michelle. So I want to give a shout out to one of our former Midday Science Cafe presenters. We've got Rachel Woods Robinson joining us, and she's asked a couple of really great questions. So here's a question from Rachel. She's usually seen that material criticality is defined in the geopolitical context of the United States and of the EU. Since the energy transition is an international endeavor, she's curious if there's a more global definition of whether an element is critical. And is there a way to assess whether something will be critical in the future when different technologies are scaled up or scaled down?
Meg, do you want to start with that one?
Yeah, I think it's a really interesting question. Because they do kind of get defined from the perspective of where you are, whether it's the United States or Europe or China also, I think, has their own definitions for critical minerals. Looking at it internationally, and usually it has to do with how dependent the economy of that place is on that mineral and how concentrated the production is. So I think that the concentrated production would probably continue to be an element of criticality. But there is a lot of kind of like, do we have a good relationship with this country where we're sourcing things from? That if you're looking at it from a more international perspective, it would be cool to see criticality mentioned more in terms of like how important is it to well-being and what is the impact of it, of producing it, and kind of have that be part of the conversation. But I don't know if that's happening. That's just what I think about it.
Yeah, as a little bit of a case study, you may have seen in the news recently that China stopped exporting gallium and germanium to the United States in response to some of the semiconductor tariffs and other things that are happening. So gallium and germanium are essential elements, critical elements for computer chips. And that's a human decision, right? That doesn't reflect any sort of geological reality other than the gallium and germanium happen to be more concentrated over there than over here. So criticality is definitely only partially a scientific concept and partially, as you say, a geopolitical concept. And I mean, just to give you an idea of how this actually gets defined at the level of the United States federal government, it's a conversation between the Department of Commerce, the Department of the Interior, and the Department of Energy to figure out who cares about what and where it is. And so it's always kind of a moving target in that way. And so each country has a different metric for that because it involves all of their trade relationships and all of the other sort of geopolitical considerations that go into that. So what we try to do is find sort of the underlying science questions that can help address criticality generally, regardless of how anyone may choose to define something as critical. But it's complicated. It's kind of inherently complicated, and it always has been. I mean, there's always been struggles over mineral resources going back, to prehistory. So it's nothing new, but we feel like there are technology solutions that can definitely help, at least in certain places, and lithium is definitely one of them.
Got it. Thanks for those answers. All good points, Mike and Meg. So I've got a question now from Meg. This is around compensation for participants who are providing feedback. So do you ever consider providing, funding for community members who participate? And this is because we often think that, we want to involve community members, but sometimes folks don't necessarily have the time to be fully involved because, they have work, as you mentioned before. Is compensation something you think about in this area?
Yeah, thank you so much for bringing that question up. It's a super important question. I think compensation is very important. In this study, part of taking the approach of like listening where people were already voicing their opinions and showing up was so that we weren't putting an additional burden on anyone when they're already kind of taking the time to express things. We did, and then the way that we kind of tried to incorporate it in terms of acknowledging people's feedback was, first of all, by providing food to make it easier for people to attend the meeting, and then also providing compensation for participating in the survey. The ideally moving forward, that would be more formalized, and there would be more formal roles for community members to participate in the research that would be compensated. I'm trying to learn more right now about what it looks like to set up a community advisory board. So I've heard about that taking place, where you have maybe 5 people who receive regular updates and provide feedback on the research, and they're compensated per meeting. That's one way of doing it. Or another model is including a community organization when you're in the grant proposal stage, and having roles and responsibilities for both. But if anybody has experience in this, please reach out to me, because I think it is also complicated to know how to set it up within the institutional funding arrangements, since it's not a typical setup where you have a student or somebody who's affiliated with the lab working on the project. And so I think, like, bureaucratically, I haven't totally figured out how that works.
Yeah, I mean, just to put a fine point on that, you said it all, Meg, but, just from the perspective of someone who's, we receive taxpayer dollars to do the research, and how do we make a justification of taking someone's taxpayer dollars and giving it to somebody else? There's an obvious justification for doing the research, but as you say, the institutional complexities make that challenging.
Thanks both. Since we're, sort of on the topic of community engaged research, I'm going to ask Meg one more question. And that is, can you share some examples of how community feedback has actually influenced the design or direction of the research that's happening at the Salton Sea?
Yeah, so within the lithium world of research that I'm a part of, for example, like I mentioned, I'm doing a life cycle, or we are working on a life cycle assessment of direct lithium extraction. And so based on these community priorities, one of the really specific changes is modeling a pre-treatment step before the lithium is extracted, because that's where the bulk of solid waste is expected to be generated. And so because community members voiced that this was a concern to them, and I realized that existing LCAs skip that step and they just look at the lithium extraction process. So that's kind of a concrete way. In the Department of Energy project, the results about the air emissions were put in the context of regional air emissions. And then similarly, the water consumption is compared, not just given in terms of like cubic meters per metric ton of lithium, but compared to, for example, how much water is used by agriculture. So that's one example. But I will say, I think in the Department of Energy study, community engagement was added after the proposal had already pretty much been funded, and the other aspects of the research were kind of already determined. And I think it is a challenge to really integrate it into actually meaning that on a broader scale, the research is also done differently and not just communicated differently. And then I also want to flag there's public health research that has been conducted in the Salton Sea region, both on the North End and in Imperial, where that has been participatory research. So I know Comité Cívico del Valle has participated in public health studies about the region. And then, and so there are much more engaged examples of that in other fields in the Salton Sea, but I don't know enough about them to know how it changed the results.
Got it. Thanks, Meg. I'm going to hand things back over to Michelle for a few questions.
Thanks, Jen. This is just super interesting. I'm going to turn our attention back into the specifics of the mining process. And as I'm looking through all the questions, I'm seeing a theme bubble up around the spent brine and concerns about what happens with the spent brine. So can you talk a little bit more about the ejection part of the spent brine into the geothermal reservoir? Is there any modeling for this?
Yeah, I can give a brief answer to that. The answer to the modeling part is yes, and it's a critical part of how this is done. because the reinjection step, yeah, it has to be done properly in order for the whole cycle to be sustainable. So there's a lot of work looking into what happens during reinjection. And I know there's some other questions about lithium recharge. So if you're injecting something down into the surface after the lithium has been extracted, are you depleting the lithium? That's an open research question. We don't know the answer to that for sure. It hasn't been done at a large enough scale where you've really cycled through enough brine volume to know how much is being depleted. So it's a really interesting question that does depend on this aspect of where you re-inject the spent brine. So we're doing modeling here. Others have done modeling as well. And it's an important question to answer. It's still very much an active topic of research.
Thank you. And I feel like I'm not this kind of scientist, so I'm not sure if this is exactly related, but I'm going to try. So there are then some differing information from someone who's heard from a geothermal industry expert about the disposal of the solids precipitated from the spent brine, and wonders about and I guess from this information that the brine cools as it rises and the solids then precipitate out at the surface and they can't be sent back down into the well. So there's some, maybe if there's some clarification that can happen around like, what is the process, what's going on? And that would be awesome.
Yeah, I mean, it's one of the world's most unique brines. It's one of the most corrosive, and it has a massively high solids content and salt content. So that's correct. There's a lot of solid, and then when the hot brine cools down, the solids precipitate out. A lot of that is silica. And so for a number of reasons, even before lithium extraction, geothermal power companies were treating the brine to reduce the silica content so that it didn't scale on the inside of the pipes and cause problems for geothermal power. So that silica is precipitated out early on in the process, and there's quite a bit of it. So the questioner is correct, and there's a big question about what to do with all of that silica. I've heard proposals to do things like turn it into sand traps at golf courses. There's a question of what sort of other things are in there besides silica. Are there heavy metals or something that might be environmentally not benign like silica is, and that is also a topic of some of the research that we're doing. Meg, I don't know if you have any more to say about that aspect of it.
No, I think you summed it up pretty well. Yeah, I think the questioner is correct. They do precipitate out silica, and like Mike said, that can have different minerals in it. Right now, each truckload is tested and then sent to a different landfill depending on whether it meets a hazardous waste threshold or not. And that just depends on whether other minerals are precipitated out for that particular batch, essentially. And then I think because to extract lithium from the brine, it has to be more clarified compared to just a geothermal power plant where they're just trying to avoid kind of damaging the equipment. So it is expected that there will be more of that kind of byproduct produced when the lithium extraction is added. But the remaining spent brine, any brine that is still in brine form is re-injected. So I think part of the goal is to keep as many of the minerals in the brine as possible.
Great. Thank you. Hopefully that clarified some of the questions around the brine, and that's awesome. Thank you. Mike, does Lyric or Berkeley Lab, do you know of, have partnerships with lithium companies in the salars of South America?
Yes, the salars in South America.
Salars, thank you.
Yeah, lithium triangle sometimes it's called. Chile, Argentina, in Ecuador. Has a lot of lithium-rich brine that is sitting right on the surface, or very near the surface, I should say. Whereas the geothermal brine in the Salton Sea is many hundreds of meters underground. So these salars are typically thought of as being a quote-unquote cleaner brine because they have less of these dissolved solids, as we just talked about with the last question. And so there are technologies that exist now that make it easier to extract lithium directly from these brines. in answer to the question, we do have some work with some companies who either produce lithium there or refine the chemical products of lithium from South America. We're primarily focused on U.S. domestic resources, but not exclusively. So we do some work with with South American brines from the salars as well.
Thank you. Sort of semi-related. Is anyone at Berkeley Lab exploring electrochemical lithium extraction from seawater then?
We are exploring electrochemical methods for lithium extraction. Seawater is an incredibly hard resource. It's not at the top of the list. I know this is an active area of research in other places, but lithium in seawater is many orders of magnitude, 10 to 100,000 times less abundant than things like sodium, magnesium, potassium, and calcium. All of these are other ions that interfere with the process of lithium capture. And so the problem with seawater is that you develop a technology that's very, very, very selective for lithium, that might grab lithium, even if it's just one part in a million of all of the things that might be found in the seawater. But because it's almost 1 million times less abundant than all of the other ions that are there, it's incredibly hard to design materials or processes that can do that efficiently. And so, we think about that because we're already developing electrochemical technologies for separations from brines, like geothermal brines or brines from the salars in South America. But seawater is a hard resource, and we don't think it's very likely to be a dominant source of lithium anytime soon.
That sounds great. Thank you. That's wonderful. I think we're right about time to start. Have one more question. I'm going to be a little selfish and ask this question because it's related to something I'm curious about as well. So the questioner asks, I'm currently a public transportation user and cyclist. However, I will need to purchase a car in the next year due to life changes. Should I go electric? And I think this is on the brains of a lot of folks, like, should I go electric when I buy my next car or my first car? So if you both wouldn't mind opining about that, that'd be awesome.
Meg, you go first.
Okay. I'm going to preface this by saying that I do not have an EV, and so I do not yet have an EV. I have a car that's from 1996, and I can't let it go because it just runs so well. But eventually that time will come and I probably will get an EV, but I can't at this time speak to the driving experience, although I hear it's great. I will say a lot of people ask me, are electric vehicles better or worse? And my response is usually, first of all, climate change is the fire that we're actively trying to put out. And electric vehicles from that perspective, particularly if you're in California or an area with a cleaner grid, are better than a fossil fuel car. I also think plug-in hybrid electric vehicles are great where you have the option to use the electric vehicle mode most of the time, and it has a smaller battery. And sometimes people will ask me which brand of electric vehicle is the most sustainable. And I don't think that there really is an answer to that besides the fact that the smaller your car, the more sustainable your battery is because you just don't need as much of it. So that's pretty much my input on that question.
Mike, do you have thoughts?
Yeah, I mean, I can't give anybody advice about what car to buy. I can say that I have an electric car and a hybrid. And I like them both for various reasons. Yeah, I think Meg's point is right, that especially in a place like California, the grid is so much more sustainable and will become even more sustainable, that going electric is probably on balance a good thing. The other thing that I considered before thinking about an electric vehicle is other things you might not think about necessarily, but that could be important to you and your family, which is things like air quality. And the air quality in the South Bay is the best in the world because it's the highest concentration of EVs, right? So that's something else that has probably a more immediate impact on your life because you're breathing the air every day. And something that I considered in making that decision. So I can't tell anybody what to do, but yeah, I certainly think, despite the fact that we've talked about issues around the minerals and the mineral supply chains for electric vehicles, I think if you did a side-by-side comparison and the same kind of spotlight was shown on the alternative, you'd still come out probably thinking that EVs were the right way to go.
Great.
Yeah,
Thank you.
just really
Sorry.
quickly, that reminds me something that we also forget is that fossil fuels also have extremely negative, in many areas, local impacts where they're produced and not just where they're burned. So when that's not part of the conversation, it can seem more like, well, we're creating a whole new problem. And so I think it's important to be aware of the potential for that as we're transitioning without losing the context of the life cycle of fossil fuels.
Wow, wonderful. Thank you both so much for answering that question. But this presentation in general, it's just been so interesting and fascinating. I've learned a lot from listening to you both. Jen, do you have any wrap up things that you'd like to share before I put our survey link up on the screen?
Sure. I just want to say thanks again to Mike and to Meg for their great presentations, and to our audience for showing up and asking great questions. If you'd like to stay up to date on research that's happening at the lab and on campus, you can visit us at science@cal.berkeley.edu or lbl.gov. As Michelle puts up the screen for our survey, we just want to remind you that we'll be back next month talking about earthquakes. So thanks again, and thanks again to Mike and Meg, and we'll see you next time.
Here's our survey link, and feel free to use your QR camera to check out the QR code. We will also send out a survey link when we email you all the recording, and then eventually we'll post it up on our various YouTube channels.
Wonderful. Thanks all. We'll see you next month.
Thank you, everyone.